We're going to continue talking about the lesson on properties of logarithms, and this is part two. Before we look at part two, remember part one was where we looked at the base change formula and we looked at what the properties of logarithms were. So if you recall, with regard to the properties of logarithms, some textbooks called it the laws of logarithm. We looked at the product rule, we looked at the quotient rule, and we looked at the power rule. And we looked at a few examples on how to apply these rules. Okay, so we did some examples using the product rule, we did some examples using the quotient rule, and we did some examples using the power rule. Now, what we're going to do in part two is we're going to continue looking at examples of using these rules, but these properties, these problems that we're going to look at will involve applying one or more of these properties at the same time. Okay? So let's remind ourselves about what the product rule says. So the product rule says that if you take the log of a product, and let's call these factors, the factor m and a factor n, and regardless of what the base is. All right, remember, your base, when you're dealing with logarithms, has to be a positive real number, and it cannot be 1. All right, so if you're taking the log of a product, then that can be written, that can be expanded. Notice I'm using the word expand. That can be expanded to the sum of the log of each factor. All right, so call these factors. When you're looking at a product, those numbers, whatever, or expressions, whatever they may be, are called factors. So it will be the log of m plus the log of n base b. All right, now for the quotient rule, remember division, that's going to be subtraction. So the log of a quotient can be written as the difference of each logarithm. Now the numerator is written first and the denominator is written second. Because remember, subtraction is not commutative. The order in which you subtract does matter. And then the power rule was where we had the log of some expression raised to an exponent. All right, some expression raised to an exponent. Regardless of what the base is, I can write this as a product. So in other words, I can write this as, I can pull this exponent out in front and write it as a product, p times the log of m base b. Okay? All right, so what we're going to do now is we're going to work some examples just like we did in part one. So you may want to go back and review those examples in part one. Okay, it's a very good idea to do that. And then we're going to notice that most of our examples that we're going to look at will involve one or more of these rules being applied in one problem. Okay, so the first few, though, will be a review from the previous lesson, so from part one. Okay, so the directions will say expand each logarithmic expression as much as possible. And then where possible, evaluate the log expression. So you're going to see what that means as we go through this without using a calculator. Okay, so number one, let's suppose I had the log of 8 times 5 base 3. And what I want you to do is to apply one of our rules, or as many of the rules as possible, okay? Because in these problems, in most of them, more than one will apply. All right, so if you look at this, I'm taking the log of a product, right? So I'm going to use the product rule. And so the product rule says I can expand this. So I'm going from a single logarithm to I'm expanding it to 2 logarithms. All right, so that's what it's saying. So that's going to be the log of 8 base 3 plus the log of 5 base 3. Okay? All right, so that I expanded. Now I'm going to go and I'm going to look at this part. Can I evaluate each log expression? In other words, remember in a previous lesson you did something like this where you had the log of, let's say, 8 base 2? And you could tell me what that is. What is the log of 8 base 2? Do you remember how we did this? So you kind of looked at this in terms of what is this equal to? So we did a box or a variable, whatever you want to use, and we converted this to exponential because this was a logarithm, so I converted it into its equivalent exponential form. So we said 2 to what power is 8, right? So 2 to what power is 8? And then you could tell me what that is. 2 to what power is 8? 3. All right. Now here, though, can you do the same thing? And notice as we go through these, I'm going to be doing this idea. 2 to what power is 8? So 3 to what power is 8? Now, remember, you want to evaluate without using the calculator. So without using the calculator, think about 2 to what nice number is 8? So 2 to the third power is 8. I can easily do this, right? So think about, is it easy to figure out without using a calculator? So is this easy to figure out without using a calculator? 3 to what power is 8? That's not easy. You need a calculator for that. In fact, you're going to need the base change formula to approximate what this is. So 3 to the second is not 8. 3 to the third is not 8. So I'm done with this part. What about this? 3 to the second is not 5. 3 to the third is not 5. So I'm done. So there's your answer. Okay? All right, number 2. So you gotta think like this before you go into the next problem. All right, so number 2, so we have the log of 7 divided by x base 2. So again, this is another review from part 1. So let's see if you kind of remember what to do there. So if you look at this, I'm taking the log of a quotient, right? So I'm going to use a quotient rule. So that's going to be the log of the numerator, base 2, minus the log of the denominator, base 2. All right, now you want to evaluate as much as possible. So this argument here is an expression, a variable expression, so I'm not going to fool with this. But ask yourself this, can you easily figure out what this is? 2 to what power 7? You can't, right? So you're done. All right. What about number 3? Suppose we had number 3. Suppose I had the natural log of the 5th root of x. Do you remember what we did there? All right, so those 3 were similar to part 1. So you learned this in part 1. So you got to remember about this. You have to remember that whenever you have a radical expression as such, whenever you have a radical expression, you got to rewrite this as a rational exponent. All right, so recall that you can write radicals using rational exponents. Okay, so in other words, that 5th root of x, I can write as x to what power? Remember, this exponent right here is 1, so you can say 1 divided by 5. So that's 1/5. So that's what you want to do here. Okay, so that has become the natural log of x to the 1/5. All right, so that's where I'm at. Now, what else can I do to this? Can I use any of these properties right here to do this? Yeah, so I can use the power rule, right? So if I look at the power rule, that means I take this exponent 1/5 and I'm going to write it as a factor in front of this natural log of x. So this will become 1/5 times the natural log of x, and I can't do anything else. So I'm done. So that's your answer. Okay? All right, number 4. Suppose in number 4, I had the log of 5x base 5. Log of 5x base 5. Okay, now, so it's very similar to number 1, right? So I'm going to use the product rule. And so that becomes the log of 5 base 5 plus the log of x base 5. Okay? But let's remind ourselves what the direction says. Where possible, you need to evaluate these log expressions without using a calculator. So if you can simplify any of these logs, then you want to do so. So if you look at this right here, can I rewrite this into another expression? Yes, you can, because 5 to what power is 5? 1. So this is 1. All right, so this becomes 1 plus, and I'm not going to do anything with this because 5 to what power is x? Well, you don't know that. You don't even know what x is, right? So that's a variable expression. Leave that alone. You can't simplify that. And there's your answer. Okay? So you got to remember some things in another lesson way back then where you had, if you had the log of let's say b base b, remember that's just 1. So whenever whenever the argument and the base are the same, it's just 1 because b to the first is b. So that's what we used here. Okay. All right. Number 5. Let's suppose in number 5 I have the log of 64 divided by y. That's y. Base 4. Log of 64 divided by y base 4. Okay, so here I'm going to say, well, that's going to be the log of 64. So I'm taking the log of a quotient, so we use the quotient rule, log of 64 base 4 minus the log of y base 4. Okay, and then remember, can I simplify anything? So whenever the argument is a number, see if you can simplify this. See if you can evaluate this. 4 to what power is 64? 3, right? 4 times 4 times 4 is 64. So it'll be 3 minus the log of y base 4. Okay? All right, so that's number 5. All right, let's look at number 6. All right, number 6, let's suppose I had this in number 6. Let's suppose I had, all right, so here's number 6. So let's suppose I had the log of m raised to the negative 6th power. So again, this is easier than the previous two, isn't it? So I'm going to use the power rule. So that's going to be negative 6 times the log of m, and there's nothing you can do with that. You can't simplify that further. Now just remember though, you see how I don't have a base listed? Remember that base is understood to be 10, so we're dealing with this being a common logarithm. All right, so there's your answer. All right, number 7. All right, number 7, let's suppose we had this. We had the natural log of e to the 7th divided by 6. E to the 7th divided by 6. All right, so now be a little bit careful here because some of you are going to have the inclination to see this exponent, you're going to want to pull it out in front. You're going to think I'm going to use a power rule right away. Can't do that. Remember, the only time you can use a power rule, listen carefully, the only time you can use a power rule, use power rule first if it looks like this. If it looks like this. The log base b of some expression raised to a power. All right? So this whole thing must be raised to the same power. So if you look at this, is this whole thing, see I have the parentheses here? Is all of that being raised to the 7th power? No. Only what's being raised to the 7th power? E. All right? So you cannot use the power rule first, okay? All right. Now, I am looking at a quotient though, so let's use a quotient rule here first. So that's going to become the natural log of e to the 7th minus the natural log of 6. Okay? Now do y'all see I can use a power rule? So in this problem I used two rules. I used the quotient rule, and I'm using the power rule. And so here I can use the power rule now, right? So that's going to be 7 times the natural log of e, okay, minus the natural log of 6. Now, simplify as much as possible. So I want you to think about this. What is the natural log of e? Remember what we did? What is the natural log of e? Think about the natural log of e. So remember, the natural log of e means the same thing as log of e base e, right? So e to what power is e? 1. So e to the first power is e. So we get 7 times 1 minus, now can you simplify this? E to what power is 6? You can't do that very easily. In fact, you can use your calculator to kind of approximate that. So that's the natural log of 6. So we get 7 minus the natural log of 6. All right? Okay, so in this problem, we use the quotient rule and we use the power rule. All right, so going from here to here was the quotient rule. Okay, and then going from here to here was the power rule. And then I evaluated. Now let me remind you about something. If I look at this problem again, I just want to show you something. So if we look at that same problem, the natural log of e to the 7th divided by 6, okay? And then I'm going to do the same thing. I'm going to use the quotient rule. So the quotient rule, I'm going to go ahead and write it horizontally. So the quotient rule will be the natural log of e to the 7th minus the natural log of 6, right? Now, you see this right here? Some of you, did you really have to use the power rule to get to evaluate this? No, because remember in a previous lesson, you learned this property. You learned about this particular property I'm about to remind you, that if you have the log of e to a power, I'm sorry, let's do b. The log of b to a power, base b. So if this base and this base are the same, remember it's just the exponent, right? So isn't that what you have here? In other words, isn't the natural log of e to the 7th the same thing as log of e to the 7th base e? So aren't these the same? So it's just 7, right? So that's one of the things you learned before. So notice the natural log of e to the 7th. If I want to find out what that is, like I did in previous problems, I would say remember the natural log has base e. So you say e to the box is equal to the argument, which is e to the 7th power. And so if the base are the same, if you want this side to be e to the 7th, then this must be e to the 7th as well. So the exponent must be 7. All right, so you could have done that way. So it doesn't matter which approach you use. Just make sure you understand both approaches, though. All right. So for many of you, though, the power rule probably would have helped you a little bit better because it's easier for many students to understand the natural log of e versus the natural log of e is 1 versus the fact that the natural log of e to the 7 is 7. It's easier for students to focus like this. Okay? All right, so that was number 7. All right, let's look at number 8. So number 8, we have the log base 4 of the square root of x divided by 16. Log base 4 of the square root of x divided by 16. Okay, so I'm going to use the quotient rule because notice the outer exponent is 1, so don't use the power rule first. All right, you use the quotient rule first. Same thing like we did here. So that's going to be, I'm going to go ahead and write it like this. So that's going to be the log of the square root of x base 4 minus the log of 16 base 4. Okay? All right, now let's go ahead and look at this. Do you remember, just like before, you always want to write the radicals as rational exponents so that way you can use the power rule. You want to write the radicals as rational exponents so you can use the power rule. Okay? Always keep that in mind. You have to do that with these. You can't leave it like this. So this becomes the log base 4 of x to what power? Okay, good, 1/2. Because the index is 2, the exponent here is 1, x to the first power, so 1 divided by 2. And I'm going to go ahead and just rewrite this for right now. Okay, now, we can now use the power rule here, right? So that becomes 1/2 times the log of x base 4. Now, can I evaluate this? 4 to what power 16? 2, right? Okay, so minus 2. And that's your answer. That's all you can do. Okay? So keep in mind, I use the quotient rule first. All right? And then I use the power rule. And then I evaluated when I could. Okay? All right, so that's number 8. All right, number 9. Let's suppose in number 9, I had this in number 9. Okay, so number 9, I have the log base b of x to the 3rd power y. Log base b of x to the 3rd power y. All right, now again, remember what we said. Can I use the power rule first? Because some of you will. Some of you are going to say, will say this. Some of you will say, well, that's going to be 3 log base b of xy. That's not true. Okay, not true. Because remember, this right here, if you think about it, this right here is really this. This is really this. Log base b of xy to the third. So is that the same thing as this? No, it's not. Because that would be x to the third, y to the third. So that's not what you have. Okay? So be careful. So don't use the power the power rule first. You have to use what rule first? Product. So you use the product rule first. So that's going to be the log base b of x to the third plus the log base b of y. Now don't forget your base. All right, so sometimes it's very easily to forget writing those bases. So make sure you do that. And now, so remember going from here to here, I use the product rule. Okay, and then going from here to here, I'm going to use the power rule. So the power rule will be 3 log of x base b plus log of y base b. All right, so you just take that exponent, put it in front, just like this, 3 times the log of x base b. All right, and you cannot simplify anything here, so you're done. All right, so remember about the things that some students will mess up on and not realize that if they wrote this like this, that is really this, and this are not the same thing. Okay, so you gotta be careful. Okay, number 10, let's suppose I had the natural log of e times x to the second power. The natural log of e times x to the second power. So I'm going to ask you this. Remember in number 9, I could not use the power rule first. I had to use the product rule first, and then I use the power rule, right? Could I use the power rule first? Yes. In fact, you want to use the power rule first, okay? So you're going to write this as 2 times the natural log of e times x like this, all right? So 2 times the natural log of e times x, okay? Now I'm going to use the product rule. So going from here to here, I use the power rule. And then I'm going to use the product rule. Now I'm going to cover the coefficient of 2 for right now. I'm going to cover this coefficient, okay? And let's just look at this for a moment. So do y'all agree that's going to equal the natural log of e plus the natural log of x, right? Okay, but remember, all of that sum has to be multiplied by what? 2. So don't forget about that. So you got to think like this. You have to think, okay, so let's deal with this expansion first. I'm going to expand this to 2 logs, but both those logs have to be multiplied by 2. Now I'm going to distribute. And before we distribute, you could do this. What's the natural log of e? Natural log of e is 1. So you could say you could say 2 times 1 is 2. You could put the 2 first if you want to. All right? But many students don't do that. They prefer to distribute first, which is fine. You can do that. Oh, I forgot the 2 here, so don't forget to distribute. But then you got to ask yourself, can I simplify any of these logs that I see? Okay, so that's the one that has an argument. What's the natural log of an argument that's a number? What's the natural log of e? 1. So it's 2 times 1. So this is 2 times 1, right? And I can't simplify this one. And what's 2 times 1? 2. So you get 2 plus the natural log of x. Okay? All right, so I use a power rule, and then from here to here, I use the product rule. And then at some point, I evaluate it. But I want to show you something. So you see that same problem? Okay? So do y'all recall? Now you got to recall this. So let me go ahead and do the recall here. So recall from previous lessons or previous courses, so from your prior knowledge, that if I have x to the b power raised to the a power. So when I have an exponent raised to an exponent, so when I have a power raised to a power, what do you do with those powers? You multiply, right? So that'll be x to the a times b, okay? And then in a previous course, you expanded this a little bit further. So you said, all right, well, what if I had x to the b, y to the c, all raised to the a power? Same thing. So since I have a product here, I can write this as x to the ab, y to the ac, right? So again, since it's a product, I can expand it. I can rewrite this as x to the a times b times y to the c times a. So that being this, so you see this right here? We have e times x to the second power. I can do this first if I want to. In other words, this right here becomes the natural log of e squared times x squared. That's what that becomes. And now if I want to, I can use the product rule at this point. So that becomes the natural log of e to the x plus the natural log of x squared. Okay? And then, I didn't mean x, I mean 2, right? 2. And then I can use the power rule. So that becomes 2 times the natural log of e plus 2 times the natural log of x. And does that look familiar? That's just right here, isn't it? And then the natural log of e is 1, so I get 2 times 1 is 2, plus 2 natural log of x. I forgot the 2 right here, by the way, so that's 2 right here. Okay? All right. So that's 2 natural log of x right here. All right. So here you could have done this two separate ways, but most students, because they tend to forget this, most students just prefer to use the power rule first and then expand it. All right, so that was number 10. Okay, let's look at number 11. So let's suppose in number 11, I had this. We have the log of the cube root of 100 times x. The log of the cube root of 100 times x. All right, so remember the radical expression, you need to rewrite it as rational expression. So do y'all agree that this is going to be the log of 100 times x all raised to 1/3 power? Okay. Now, you remember this right here now looks like this. I would work it out this way. I would not attempt to do this. I would just use the properties of logarithms here. Okay, so we have, so I'm going to use the power rule first. So that's going to become 1/3 times the log of 100 times x, right? So all I did was use the power rule. Then I'm going to use the product rule. I'm going to cover up the coefficient of 1/3. So I'm going to use the product rule here. So it becomes the log of 100 plus the log of x. All right. Now remember that all that's being multiplied by 1/3 though. So at some point I'm going to have to distribute. But before I do that, let's look at the log of 100. What's the log of 100? All right, well, the log of 100, remember, if there's no base there, it's going to be 10, so we're dealing with the common logarithm. 10 to what power is 100? 2, right? Okay, so do y'all agree that's 1/3 times 2 plus the log of x? All right, so remember the log of 100. Okay, so you can say 10 to what power is 100? That's what you did in your mind. So 10 squared is 100. All right, and then distributing, I get 1/3 times 2 is 2/3, and then 1/3 times the log of x. All right, so that's number 11. Okay, number 12. All right, 12, suppose we had this. We had the natural log of the square root of e times x. Natural log of the square root of e times x. Okay, well, again, let's rewrite the radical using a rational exponent. So that becomes the natural log of e times x in parentheses raised to the 1/2 power. All right. So remember, you must write radicals as rational exponents. All right, so make sure you go back and look at every problem we've done with radicals. You need to look at what we've done. That's important. Okay, so now since I'm taking the natural log of some expression raised to a power, so this whole thing is being raised to a power, I'm going to use a power rule. So it's become 1/2 times the natural log of e times x. All right, so I'm going to use it. So I went from here to here. I used the power rule. All right, now I'm taking the log of a product. So I'm going to use the product rule now. I'm going to cover up 1/2 for a moment. So that becomes the natural log of e plus the natural log of x. And all of that's being multiplied by 1/2. But I know what the natural log of e is. What's the natural log of e? The natural log of e is 1. Remember, a natural log has base e. So e to what power is e? 1. So remember, e to the first is e, right? So that's how you get that 1 right here. So that becomes 1/2 times 1 plus the natural log of x. And then distribute. I get 1/2 times 1 is 1/2 plus 1/2 natural log of x. All right, so that's number 12. Let's look at 13. So remember what we did. We use a power rule, and then I used the product rule, right? And then I evaluated. All right, 13. Let's say we had the log of the 6th root of x divided by y. Log of the 6th root of x divided by y. All right, so again, rewrite the radical. So that's going to be the log of x divided by y, all raised to the 1/6 power. Okay, so that and that are the same thing. And then I'm going to use the power rule. So that becomes 1/6 times the log of x divided by y. So go from here to here, I use the power rule. All right, now notice this is a quotient, so I'm going to use the quotient rule. So I'm going to cover up the 1/6. That will be the log of x minus the log of y. And all that has to be multiplied by 1/6. So now I'm going to distribute, and I can't evaluate anything since my arguments are variable expressions. So I'm going to get 1/6 log of x minus 1/6 log of y. 14. Okay, in 14, we have the log base b of x squared y divided by z squared. Log base b of x squared y divided by z squared. Now, if you go back to the few examples we did previously, notice that in most of those examples we did, we used two properties. We used a power rule, and in this case, we used a quotient rule, right? In some of them, we used the power rule with the product rule. Right? But now what's going to happen is that this right here is going to involve all three. This is going to involve all three because notice you have an exponent, you have what else? A product, and you have what else? A quotient. Okay? All right, now, the order in which you want to do this is this. So if you go back in the previous two we did, so this one, so notice this one involved the power and the quotient, right? And this one involved the power and the product. Which one do we do first? In both of them, to make things easy on ourselves, which one always came first? The power. So if possible, always do the power rule first. If possible, use the power rule first. Okay? Now I'm going to ask you this though. Can I use the power rule first? In other words, can I pull this 2 out in front? No. Because this whole thing is not being raised to second power. Okay? But if possible, you do that first. Okay? Then you can do it in this order. Then you're going to use the quotient rule next. So whenever you involve a quotient and a product, just like this, you can do the quotient rule next, and then last, product rule. Okay? All right, so that's the order. So you go in that order. So you can ask yourself, can I use a power rule first? No. So then you go to what? The quotient rule. Okay, let's go to the quotient rule. That's how you're going to think about this. So that's going to be the log base b of the numerator, minus log base b of the denominator. So notice I put the numerator in parentheses because that was a product. That was several factors here, and that was just one expression, z squared. So I did not need parentheses there. Okay, now look at what you have. At this point, what are you going to do with this that I'm circling? You're going to use the product rule. All right, so let's use the product rule. So that becomes a log base b of x squared plus the log base b of y minus the log base b of z squared. Okay, so going from here to here, I use the quotient rule. And then going from here to here, I use the product rule. Okay? All right, now, what's the last thing I need to do? So it's kind of like you're going into a circle here, like this. So can I do this? No. Then you go to this, and you go to this, and you come back. So now I can use what? The power rule. So this becomes this becomes 2 log base b of x plus log base b of y minus, and then use a power rule here, 2 log base b of z. And so you can do. You can't evaluate anything. All right. So from here to here, we used the power rule. Okay. All right. So that was 14. Let's look at 15. So in 15, we have this. We have the log base b of x cubed y squared divided by z to the 5th, all raised to the 8th power. Okay. Now remember that process we said, if possible, do the power rule first. So here I could not, because this whole thing was being raised to the first power, not 2. See, it's only this, and this is being raised to the second. So you cannot do the power rule first. So in this case, though, can I? Yes, you can, because the whole thing here, everything that's inside the parentheses, is being raised to the 8th power. So I'm going to use the power rule first. So I'm going to get 8 times the log base b of x cubed y squared divided by z to the 5th. All right, so I use the power rule first. Now remember, the next thing we have to do is quotient. So whenever you have a quotient or product together, you got to use a quotient first. All right, so this is going to become, right here, I'm going to cover up the 8 for right now. So that's going to become the log of log base b of x cubed y squared minus log base b of z to the 5th. Okay, you all agree that that's this, right? Okay, now don't forget though, all that's being multiplied by 8. Now before I distribute, I wouldn't distribute yet. I would distribute at the end. Okay, so before I distribute, let's do the product rule next. So that's going to become 8 times, okay, this becomes the log base b of x cubed plus the log base b of y squared minus the log base b of z to the 5th. Y'all agree? Okay. And even before I distribute again, I'm going to go ahead now and use the power rule. So I use the power rule here. Going from here to here, I use the quotient rule, right? And then going from here to here, I use the product rule. And do y'all agree I'm going to have to use the power rule again? Okay, so using the power rule again. So I get 3 log of x base b plus 2 log of y base b minus 5 log of z base b. So I had to use the power rule again. And now I can distribute. Okay, so I get 8 times 3 is 24. 8 times 2 is 16. And then 8 times 5 is 40, so negative 40. Okay, and since all the arguments are variable expressions, I'm going to leave that alone. Cannot simplify, cannot evaluate, so I'm done. All right, so that was number 15. Now I want to do number 15 again, but remind us about something we did earlier. Let me see if I can find it. Do you remember when we did number 10, we talked about this property right here? Okay. Let's go ahead, and even though it's usually easier for students to understand how to expand by using the power rule first in this situation, let's do this again. I just want to show you something. Just to remind you about some properties you learned in a previous course that can still be applied here. All right, so this is going to be 16. Same problem, it will be the same problem as that one. So we have the log of base b of x cubed y squared divided by z to the 5th. So basically what I'm going to do is I'm going to use this property right here, that when you have a power raised to power, you multiply. Now remember, and that's all being raised to the 8th power. All right, so remember, you have, if you look at the numerator, you have x cubed to the 8th, xy to the 8th, right? Times. So that's a product. So since that's a product, that means I can write this as x to the 3 times 4 is 24, and then 2 times 8 is 16. Okay? Divided by, let me make that a little bit bigger, divided by, and the same thing here. That's z to the 5th raised to the 8th. Z to the 5th raised to the 8th. So that's 5 times 8 is 40. Okay? Now, do those exponents look familiar? 24, 16, 20. That's these, right? 16, 40. That's these. So I used, to go from here to here, I used a property from a previous laws of exponent from a previous course. Now I'm going to use the quotient rule because you got to do the quotient before you use the product. So that's going to be the log of x to the 24th, y to the 16th, minus the log base b, minus the log base b of z to the 40th. Now I'm going to use the product rule. So that's become the log base b of x to the 24th plus the log base b of y to the 16th minus log base b of z to the 40th. And now I'm going to use the power rule. So it becomes 24 log of x base b plus 16 log of y base b minus 40 log of z base b. And that's the same thing you had doing it this way. Okay? So I just wanted to remind you about something you had in a previous course that could be applied here. Okay, so that is the lesson on part 2 of our properties of logarithms. And so in this case, we're just expanding. So remember, expanding is where you go from one logarithm to multiple. In part 3, we're going to look at condensing. So that's where we're going to go from multiple logarithms to 1. All right, so that's going to be the next lesson. Okay, so that's the end of part 2.